Good evening, ladies and gentlemen. Welcome to another set of tutorials with me, Aubrey. In this lesson, we look at some examples from statistics, as you can see here. So the question reads, the table below gives experimental values of pressure P of a given mass of gas corresponding to values of the volume V. The relationship having the form PV, this is mu, is equal to C. Okay, then we have C and mu are constants. Alright, and we are asked, we've been given this data right here. Volume is that, and that, and pressure is that, and that. Now what I want you to take note here is that we've not been told if it's a y on x or x on y problem, so we should take this to be a default. Okay, we should take this to be a default in the sense that the top row represents x variables and the bottom row represents y variables, and secondly, this should be taken as a y on x as a default. So whenever you're not told, or maybe you are not very sure about whether it's y on x or x on y to go with, just take the top row as the x variables and the bottom row as the y variables and take it as a y on x problem. Okay, so now we know for y on x, the equation is represented by this: y is equals to a plus bx. Alright, and in our given, we've been given this equation here. Let me see. Right, this is the relationship we've been given right here. Alright, we can introduce natural log both sides so that we drop this power and make it a linear. Right, once we do that, we know the property when we have two variables multiplying in the natural log, we are always going to separate the variables. So this will always be equal to natural log of a plus natural log of b. Applying this here, we're going to have natural log of p plus natural log of v to the power mu is equal to natural log of c. Alright, so this is how it will come out. And another property from logarithms, we know that when we have natural log of a raised to a power, we can drop the power. So this would be k natural log of a. So we can apply this property here. So we can drop this mu right here, and we are going to have, let me have some space here. We're going to have natural log of p plus mu natural log of v is equals to natural log of c. And we need to rewrite this equivalent to our y on x equation. We see that there is something here, a natural log of v, and there is in c we've been told that is a constant, so there is in c, meaning that in c will also be a constant. In p will not be a constant because p is a variable and v is a variable. So meaning that when we rewrite, we can make in p the subject of a formula, which is in p will be equals to natural log of c natural log of v. So natural log of p will be equals to natural log of c minus natural log of v. This is comparing it to our equation here. So meaning that this is our y, our a is this, our b is negative mu, and our x is natural log of v. Okay, and the reason why we've replaced the c here, because c is a constant, p is a variable, and v is a variable. Same applies here. Y is a variable, x is a variable, b is a constant, and a is a constant. Same applies here. Mu is a constant as well. So writing what we were saying, meaning that y is equals to natural log of p, A is equals to natural log of C, B is equals to negative mu, X is equals to natural log of V. Okay, these equations are very important because they will help us find C and mu. So C is this C equals to A. Okay, yeah. So this is C. To find C, we need to find A. Okay, and this is mu. To find mu, we need to find B. Now, how can we find B and A? So now we'll create a table. We have the V variables here and the P variables, and we know that X is equals to natural log of V, meaning that here we are going to punch in to find X variables. We're going to find natural log of these individual variables. Natural log of 54.3, that will be the equivalent of X here, which is giving us 3 point that. Natural log of 61.8 is giving us that. Natural log of 72.4 is giving us that. Natural log of 88.7 is giving us that. Natural log of is giving us that and that. Same applies to Y. We know that Y is equals to natural log of P, meaning that Y is equals to natural log of 1.4 and so on and so forth. And we get. So now here we need to find our X times Y, which is just multiplying these variables across. Then our X squared, meaning we'll be squaring each of these variables and replace here. Our Y squared, we'll be squaring each of these variables, we'll replace here. Then from here, we'll find our B, okay, which is equals to S X Y over S X X for Y on X. And after we find our B using that, we use this equation to find our A. Plus BX bar to find our A. Okay, then from here we'll replace in our equation Y is equals to A plus BX. Okay, we'll replace our B and our X there. Then from there we now come here. Okay, so after we find our B, you just say, how do you find natural log of? You have our A here and you're looking for C. Remember, you're looking for C. For B, you just equate this. You equate this to this to find your mu there. Okay, then for natural log, for you to find C, you have to convert this to into exponential form. Remember, log of A to the K is equals to N. In exponential form, it will be A to the power N equals to K. And that is what will happen here. This is the same thing as, or let me say this. In this case, let me do this. Okay. A is equals to log to base E of C. Natural log is the same thing as log to base E. So converting this into exponential form will be E to the power A is equals to C. Okay, so you raise E to the power A and that will be your C there. Okay, so this is the task I'm going to leave you with. You finish up this and let's see what you will do.